This is Lesson 3, Experiment Part 1. I'm going to read the directions and then show you an example. It says, using Marble Launch Pad 1, place 3 marbles in the large circle on your launch pad and 1 marble, the launching marble, in the small circle of your launch pad, like the example shown. Then, holding your pencil like a pool stick, you will line up the end of your pencil to the end of the launch pad and nudge your pencil towards the launching marble, aiming it at the 3 in the center. Make sure that nothing new is in the way. I'm going to go ahead and show you this example, and then you can answer what happened in the middle. So here we are. I'm going to aim all the way down here. So here's our launching marble. And here are 3 marbles in the large launching mat. And I'm going to nudge this marble at these 3 marbles and watch what happens. At the bottom of the page, describe what happened to the 3 marbles in the center. Did the marbles all go in the same direction? Newton's first law states that objects need force in order to move. What force was it that caused the objects to move? If you need to go back and watch the example video again, then watch me again. Continuing on to our example part 2. This time again, we're going to use our Marble Launch 1, and we're going to place 3 marbles in the large circle and 1 marble on the end, just like we had before. But this time, on the end, I'm going to put a ruler on the launching mat that's going to create kind of a back block. And we want to, again, shoot it like a pool cue, aiming towards the marbles in the center. And then we'll describe what happened to the 3 marbles in the center. So I'll go ahead and show you this example now. So here's our launching marble, here's our 3 marbles, and now we've added a ruler on the back side. So we're going to see the difference between our first example and our second example. Here we go. Oh, that wasn't a very great one. Let me try again. Only 1 marble moved. All right, here we go. Kind of a different result from the first time, right? So it says, describe what happened to the 3 marbles in the center of the circle. And then it says at the bottom, the second law of motion states that forces can slow down, speed up, or change the direction of an object. What force in this experiment caused a change of direction? So the marbles were going one way, and then they changed and they went another way. What caused that? If you need to go back and watch the video of the experiment again, then pause and go back and watch the video. All right. Experiment part 3. Now we're going to use Marble Launch 2, and we're going to set up a marble on each end. And then we're going to take both pencils and we're going to nudge both pencils at the same time towards the middle. And we will see what happens when the 2 collide into each other. Remember, after we watch the example, you're going to answer the question, what happened to the direction of the marbles when the 2 marbles collided or bumped into each other? Are we ready? So here, this is Marble Launch Pad 2. So instead of having 1 circle on the one end, it has a big circle in the middle. And I'm going to take these 2 marbles and bump them into each other. It is important to know that these marbles are about the same size and about the same weight. I'll also show you an example of one that's a slightly lighter marble. So here, 1, 2, 3. I'll do it again. What happened to our marbles when they bump into each other in the middle? 1, 2, 3. And this time I'm going to change out for a really light marble. This marble is really light, so we'll see what happens to this silver marble when the two bump into each other. 1, 2, 3. Oh, they have to actually bump into each other, Miss Lynch. 1, 2, 3. So you can see a difference. The silver marble, which has much less mass and much less inertia, reacted way different than the other marble, the glass marble. 1, 2, 3. So again, in the middle part of your paper, you're going to answer what happened to the direction of the marbles when marble 1 and marble 2 bumped into each other. The third law states that if one action acts on an opposite, then there will be an opposite force pushback. When the force of marble 1 hit marble 2, what force pushed back marble 1? So when they hit together, what made them go back apart? Great job with this lesson so far, 5th graders. Before you're finished, there's a journal question to answer. It says, in experiment 1, you placed 3 marbles in the center of your launching mat. Then you used a 4th marble of the same size to roll towards the 3 marbles. What do you think would have happened if the 3 marbles in the circle had have been heavier than the really light launching marble? How would that have changed the experiment? Make sure you answer in a complete sentence. And then lastly, this has our learning focus target. You're going to move the red X to where you feel like you understand this lesson. And I performed the experiments, but do you feel like you got it? Or do you feel like maybe not so sure you want to go back and watch again? Make sure you rate yourself with the big red X and then explain why you gave yourself that rating in a complete sentence. Great job, 5th graders.